Hello everybody, welcome to this webinar for ITRS Uptrends. Today's topic is going to be API monitoring. Quick introductions, I'm JP on the left here. I am a product manager for the Uptrends product at ITRS. And in a few minutes we will be hearing from Steph, product specialist and lead support engineer for Uptrends. Let's take a quick look at what we have in store for you today. API monitoring is the topic, and conscious that we have a varied audience here today, let's briefly paint a generic picture of what APIs are about and where they operate, which will lead us to the question of why it is helpful to have API monitoring in place. Then let's have an overview of the key ingredients of API monitoring, which should set everybody up for following along with the juicy part of today's webinar, the hands-on demo that Steph will be doing. Now, the very nature of APIs will make this demo a little bit technical, but we'll set things up from scratch, start out small, and gradually build out a demo scenario that executes multiple API calls in a sequence. Then, after the demo, we'll finish up by taking a look at some really interesting new features that we're about to release. Those features include custom scripting for doing really specific scenarios and powerful content checking, and also monitoring Postman scripts. So if your team is using the Postman tool to build and test APIs locally, make sure to stick around till the end to get a first look at what that will look like. But before we dive in, let's consider for a moment what APIs are. APIs are used to let different software systems talk to each other. The system that calls the API is the so-called client, and it can request data from the API in order to show data in the client application. And if a user or a different software system wants to take additional steps for retrieving or modifying data, the API will have other calls for that. So a step-by-step going back and forth between a client application and an underlying API. You might see it happening between a website as the client application, for example, the front end of an e-commerce website that directly connects to an API that is basically the conduit to the underlying backend systems. Could also be a bit more layered, where a website first connects to some middleware that first performs its own business rules before it connects to an API, and any data going back and forth passes through all these layers. Also consider mobile apps, which typically rely on an API to retrieve data and send data back when a user modifies something in the app. But many APIs are created not to service a user-facing front end in web or mobile, but to directly create a connection between backend systems. For example, if you are a vendor of products that are sold by other e-commerce sites, you want them to be able to have a list of your products so they can include them in their overall product catalog. And a public-facing API lets you do that. And something similar could be happening inside your network, connecting different systems together. And depending on your business and system setup, you could be the API owner or an API client or both. Whatever the case may be, you will benefit from monitoring those APIs. So keeping those different scenarios in mind, let's talk about why API monitoring is useful, how it actually adds something to the monitoring we may have already set up. I mean, can't we just put monitoring on the website? That is the visible part of the journeys that my users go through. Doesn't that already give me end-to-end monitoring? Well, yes, it does. If you use our transaction monitoring to test user journeys in a browser, then you have already covered a large part. But let's also consider these aspects. If your API is down completely, your browser-based monitoring will probably detect that, as it will affect your user journeys. But problems may not always be so obvious. We've seen cases where an API that was responsible for returning a list of products only returned 10 products instead of many thousands of products because of some underlying data issue. but you won't immediately see that in a browser if a product page only shows 5 or 10 products at a time. And with API monitoring, you can count how many products the API returns and alert if that's not a sensible number. It's a much more direct way of looking at the data. Secondly, the team that's responsible for your site or your commerce platform is likely a different team than the one looking after your APIs and your backend. Even if a problem is detected using browser-based monitoring, finding the problem, understanding what's causing it, and finally realizing, oh, this is an issue in the backend, that will take time to trickle down through the different groups in your organization. So the takeaway here is it's good to have browser-based monitoring for your web team alongside API-based monitoring for your backend teams. Give them dedicated monitoring for the stuff that they are responsible for. This will give faster time to resolution. Another way to leverage API monitoring is to help out with mobile app monitoring. Doing live mobile app monitoring from a functional and performance perspective, end to end, is hard to do. Monitoring the API endpoints used by a mobile app helps you to at least have a partial view on how your mobile app is doing. And finally, on this slide, if you own an API that is published to the outside world, whether its clients are your direct customers or suppliers or other third parties that you actually rely on, you should make sure you have independent monitoring on your APIs. Just like web pages for human users, APIs are your connection points to other systems which can suffer from the same issues. Plus, it's relatively cheap to do high frequency API monitoring every minute compared to the 5-minute based browser monitoring. So you'll find out quicker as well if there's a problem. Now, I'm nearly ready to hand over to Steph for the demo, but let's review the key components again before we dive in. The API monitoring we're talking about today is about HTTP-based APIs. So it's about defining and firing off separate HTTP requests, waiting for the response, and then doing checks on that response. So single-step API calls are covered, but sometimes you need multiple steps, either because you need to perform some authentication first to get an API token, or because your API dialog just needs a sequence of steps to get to the end result you're after. And that's when the step chaining comes into play. Whatever the user selected in the previous screen, in a mobile app for example, must now be fed into the next API call to support that sequence. Now, a great asset of the Uptrends API monitoring solution is that you don't need to know how to code. Without any coding, you can get a whole lot done in our point-and-click user interface, and we'll see that in just a second. And even without any coding, we do allow you to set up extensive checks on the data returned by your API, so your backend monitoring is set up tightly. And that is a pretty compelling set of functionality that we're happy to now showcase in the demo. So over to you, Steph.
Thank you very much, JP. Hello, everybody, and thank you again for joining us. My name is Steph Hagen. I'm the lead support engineer at ITRS Uptrends, and today I will be demonstrating Uptrends' multi-step API monitor type for you. For the purposes of this demo, I'm going to be using the API for galacticresorts.com. This website is our demonstration website, which we use for demos like these. On its surface, it allows for users to book holidays to distant planets, both through the interface we see here on the website and through the attached API. There is no actual backend. Unfortunately, we don't actually sell planetary holidays, but it will work for the purposes of this demonstration. As you can see here, I have the API specification page open, which I will be referring back to at various points throughout the demo. To set up API monitoring, it's important that you have a good understanding of the API you want to test, what requests it supports and expects, in which format, and how it should respond to those requests. So for this demo, I will be showing some of the features of our multi-step API monitor type by setting up a new monitor that goes through various steps interacting with the galacticresorts.com API to retrieve information about the holiday destinations on offer, retrieving an access token, and then we'll use that access token to create a new booking. I'll be showing how easy it is to configure such a monitor, the various checking mechanisms that it supports, and we'll take a look at what the results look like. It is worth noting that everything I will talk about today was documented in our knowledge base, which is freely available via uptrends.com in the support center under the Learn menu. If you have any interest in any of the features that will be highlighted, or if you would like more information in general, I highly recommend you check out our documentation or contact your sales representative or the supports team. So without any further ado, let's get started. We are currently looking at an Uptrends account with 6 monitors in it. I'll be creating the new multi-step API monitor in this account, which I can do by simply going to API in the menu and clicking this plus button. Please do note that you need to have API credits available in your account for this, so if the menu item or button don't appear in your account, please contact your sales representative and we'll add some credits so that you can try it out. Let's give the new monitor a fitting name. Select multi-step API. Give it a fitting name such as MSA for multi-step API, demo, and then for the rest, I'll be sticking with default settings. The multi-step API monitor type is primarily configured in the Steps tab. So this is where we'll be configuring our steps, obviously, where each step consists of a request made to an API and then the subsequent handling of its response. Let's get started with configuring our first step by consulting our API specification. The first request we'll be going to make is to retrieve a list of all holiday destinations on offer. So for that, we can execute a GET request to galacticresorts.com/API/destinations as per our specification here. I'm going to right-click this link and copy the request URL out of this page. Back in the settings of the monitor, I can fill in that same request URL in the field here. I currently do not need to change the HTTP request method in this case since we're making a GET request and that is already the default value, but it is worth noting that we do support the most common request methods. Later on in the demo, we'll be doing a POST request, but we do support some of these other ones as well. If required, I can specify any manual request headers here, or I can set up one of the out-of-the-box authentication methods. We support out-of-the-box basic NTLM and digest or client certificate-based authentication. It is worth mentioning that you can upload your own client certificates to the vault in your account for secure storage, and then from there, those certificates can be used in multi-step API monitoring for advanced authentication. For this particular request, however, I don't need to set up any authentication since it's a simple request of a public API, nor do I need to specify any manual headers aside from the default ones that are automatically generated. I'll give my step an appropriate description, such as retrieve destinations. For now, my request looks good, so let's execute it and see what result we get. We'll run it from the checkpoint in Amsterdam in this case. I will click test now, and the request is currently being executed on our checkpoint in Amsterdam. Unfortunately, this API, because it is a demo API, has the tendency to be a little bit slow at times, as is the case right now. But there we go. So the check result itself contains all the usual information, the total load time, information about the checkpoint that executed the check, the resolved IP address of the request URL, as well as information about all of the steps that were executed as part of this monitor check. We can see that step 1, which is the only step right now, took a little over 20 seconds, and it was a GET request to the galacticresorts.com/API/destinations. I can expand request headers and content. We can see the request headers that were automatically generated by our system, like the host and accept encoding headers. Since it is a GET request, there is no request body. In this case, we will be seeing a request body appear later on. The response tab shows the headers and content that the Galactic Resorts API responded with. When I look at the response content, we see a JSON array of individual destinations. Each object in this array, so that is from here to here is the first one, contains information on one of the 3 destinations on offer, such as its name, a price, a link to an image, and a unique product ID. Here for the first one, the second one will be down here, and so on. So now we have a request configured that retrieves a list of destinations through our galacticresorts.com API. So let's take a look at what we can do with the response now. So for example, the API specification lists a request for API/destinations/product ID, with which we can retrieve information about a specific destination. So for us to be able to make that request, we need to add a product ID to the request URL. Using the multi-step API monitor type, we can parse the response from the first step, so that JSON response, the complete list of destinations that included the product IDs. We can isolate one of the product IDs from there, save it to a variable, and then reuse that variable in a subsequent step. So back in the monitor, in the response tab of the first step, we can set up assertions, checks to verify the correctness of the response, which I will explain further on, and we can add variables. So in this case, let's set up a variable to pull a value from the response to this step. The API responds with JSON, so I can leave the default value here, but we can also parse the response as XML, set it as response body as text, and use regular expressions. Or alternatively, we can source a variable from things like request headers, cookies. But in this case, I'll leave it to response body as JSON, and I will fill in the correct JSON expression, the first value of product ID, to grab the first value of product ID from the response. Now I have to give my variable a name so that I can refer to it later on. I will give it the same name, product ID, once again. So now the monitor is configured to execute the request to retrieve the list of all destinations and then save the value of the first product ID in the response body in a variable named product ID. I can now reuse that variable in subsequent requests. So let's add a new step by clicking the Add Request Step button. Again, I'll give my new step a nice description like retrieve first destination. So as per the specification, the request URL should be, I'll copy this link, /API/destination/ and then a value for product ID. So I will fill that in here. Product ID. So I'm now specifying the product ID in the request URL, and I'm doing so by wrapping the variable name of the variable that we set up in the first step in these curly brackets like so. So now I have the monitor configured to retrieve a list of all destinations in the first step. It pulls the first product ID out of the response, and then it reuses that value in the second step. I will run another manual test, and then we can see what happens here. So the first step will have remained the same, but now we've added the second step. Again, we will have to wait slightly for the response here, unfortunately. And there we go. So as we can see, the first step remains the same, but now we've added a second step. In the first step in the response, there is the first value for product ID here. And as you can see in the URL for the second step, we refer to the variable pulled from this first step, so this particular value, and we filled it in the URL like so. And then in the response tab for the second step, we have retrieved information. It is no longer an array, but just information for the first destination. Another example of a common use case would be authenticate a request using an authentication token that was retrieved from a separate server. So in this example, if we look at the specification, we can see that in order to make a reservation down here, we have to submit an authentication token. So we should add a step to our monitor to retrieve a token via the authentication API, which is specified up here, which is a GET request to galacticresorts.com/API/auth, so that we can then pass it along to make our booking. So we'll do the same thing again. For this step, I've once again copied the request URL from the previous steps. I'll add another request step, give it a suitable description, retrieve auth token, and it should be a GET request to galacticresorts.com/API/auth. In this case, I don't need to specify anything further, but typically for such use cases, you would add basic authentication credentials to the interface here, a username and a password. Let's execute the monitor to see what response we get to this particular request in step 3. There we go. In the monitor result currently, we can see that step 1 and step 2 have remained the same. And now for step 3, we are grabbing an access token. So in the response to this step, the API has sent an access token in this access_token field. So it's this particular value. So now we need to grab this value out of the response. So again, I will put this on my clipboard. And there we go. In the response tab for this step, we need to add a variable. Again, we'll leave it to response body as JSON because there is a JSON response. And then we need to fill in the JSON expression, which is access_token in this case. I'll reuse the exact same value as the name for the variable so that we can refer to it later. So now we've configured the monitor to pull the access token out of the API response, and it's time to configure a step to actually create the booking. In the specification, we can see that this request must be a post request over here to /API/reservation, where we'll have to specify an authorization request header, some URL encoded form data as the response body, the request body. I'll add a final step. I'll pull this URL out of here. I'll add a final step to my monitor definition and set it to a post request. Then as you can see, the request body field appears over here. My request URL should be /API/reservation. I will add a manual request header, name it authorization bearer, and then a reference to the variable that I saved in the last step, which is access_token. I'll pull my request body out of the specification here. We can make do with the default value. So this is URL encoded form data. We have a name. We're referring back to the product ID, which already contains the variable reference of the variable that we created in step 1. And then we're listing a number of sols, which is the number of days that we would like the reservation to be for. We haven't yet specified this variable, so I will just hard code a number in here for now. So as you can see, we automatically determine the type of content we'll be posting. We added this automated header here. The automated content type header automatically determines that this is URL encoded form data. And so we automatically put that header in here. I've set up the reservation request, so let's run the monitor once again from our checkpoint in Amsterdam. And there we go. So step 4 at the bottom here is a post request to /API/reservation that apparently succeeded. Under request headers and content, we can see the headers is automatically generated and also manually specified. I specified an authorization header that automatically masks the result here, the value of the token. The request body, which contained the variable reference to a product ID as specified in the first step. It has automatically resolved it to the correct product ID, the same one that we'd already used in the URL of step 2 up here. Then finally, when we look at the response body, we can see that it contains a message reservation created. So it would make sense to do a final test to check if the API has indeed responded with this specific test to ensure that the reservation process works correctly. So in the monitor settings, let's add an assertion. So these are one of these checks in the response tab for step 4 here. I will add an assertion, which is a check. The interface is mostly the same as setting up a variable with a few different options. So in this case, I still want to parse the response body as JSON, and I want to check that the message field contains, for example, the text reservation created. For illustration, let's add another assertion, for example, to check that the duration of this particular request step is less than, let's say, 5,000 milliseconds. All right, so now I have my monitor fully configured. I'm going to run one final check. As we can see, I have a completely okay result now. So to recap, step 1 retrieves a list of destinations, saves the product ID of the first destination, this value in a variable. We reuse that variable in the step 2 request URL to get information about that specific destination. Step 3 retrieves an access token and then saves that to a variable. Those two variables, the access token and the product ID, are then reused in the request made in step 4, the post request, to make the actual reservation with the access token as a header and the product ID variable used in the request body down here. The final step has a set of assertions you can see here. To check the validity and the timeliness of the response, which we can see the assertions all succeeded here. So from this point on, the monitor's requests have been correctly configured, and we can look at the rest of the monitor setup as we normally would. So things like checkpoint selection and stuff like that, alerting coverage, all that sort of stuff. That is all for the demo. I will now hand over back to JP, who will talk about some exciting new features for the multi-step API monitor type that are coming up. So back to you, JP.
Thank you, Steph. That was a great run through. I'm sure that gave a lot of insights. Now, conscious of time, I'm going to wrap this webinar up very quickly, but not without sharing a few words about two upcoming features that we will start enabling very soon. The first one is custom scripting. Today we talked about not needing any coding skills to get powerful API monitoring, but for those who do want to add their own scripts, that is now possible. The scripting is JavaScript based, and it lets you add all kinds of custom logic for checking your API data, performing consistency checks, doing calculations, anything you need. You may have existing scripts lying around. It should be pretty easy to fit those in. Also, if you have APIs that require custom authentication rules to be able to access those APIs, you will benefit from this a lot. So custom scripting based on JavaScript coming this month at no extra cost. Stay tuned for the announcement in Uptrends itself. And then the second feature, which is essentially a brand new type of API monitoring, is the ability to run Postman scripts. Postman is a free tool, kind of an industry standard tool that almost everybody uses to do manual API testing on their own machine. Postman also allows you to have custom scripts, similar to the ones I just mentioned we're adding to Uptrends. And so many people have Postman scripts lying around for internal testing. And we can now take entire collections of Postman scripts and run them for you automatically on any Uptrends check location in the world. You don't even need to convert them, you just need to export them. Postman lets you do this in several ways. And we will start checking them for you every minute, every 5 minutes, all around the world, whatever you need. So stay tuned for news on that. Again, we will announce this in the Uptrends app coming very soon indeed. That's all the stuff we had for you today. Now we really want you to start trying API monitoring if you haven't done that already. It's possible that you don't have any API credits in your account because you're all out or never purchased any. But we've got you covered. Just ask the support team and they will let you try it for a while for free. If your account administrator didn't give you permissions to try any of this, feel free to create your own sandbox. Sign up for a free trial account if you want. We'll let you try it for free that way. And if you would like to play around with the API that Steph used in the demo, that's available to you as well. The link is at the bottom of the screen there. And finally, we can help you build your API scripts. The support team is happy to help you if you have a special case or if you're struggling to figure it out. Support comes for free as well. All right, I hope you found this helpful. A recording of this webinar will be made available very soon. Thanks for stopping by and see you in the next one. Bye-bye.